electronics user groups, it had more of a focus on hardware than the modern Linux user groups do, because people were often building their own computers. They were toggling the switches on the front and they were getting in with soldering irons and things. So perhaps more like an electronics club now, but with a focus on building and using and programming microcomputers. And so these microcomputers really arose from the hobby electronics community. Then a counterpush started, and in particular there was a letter that Bill Gates wrote, an open letter to hobbyists in 1976. And in that letter, Bill Gates chastised the community for sharing software with each other, right? And he tried to say that this is wrong, that software should be sold and should be developed commercially, and that's how things should be done, right? That was his attitude on the way software should be done. And that letter is one point you could say is a start of the proprietary software industry. There was proprietary software before that time, but that sort of set the scene for the split between the hacker community, the hobbyists, and the proprietary software community as epitomised by the rise of Microsoft. So, at around this same period, there was a lab at Massachusetts Institute of Technology, and that lab was called the AI Lab, and they had a very strong hacker culture. That hacker culture had some interesting pieces to it. For example, nobody had any passwords on their accounts. Everyone could just access anyone else's accounts. And I believe that somebody at one point tried to add a passwording system, and immediately the policy was just to write people's passwords up on the board or to bypass the system, right? It was a very much an open type computing environment, everyone helping other people. Hacking on the operating system was normal. People were constantly changing the operating system itself. In fact, the operating system that they were working on was called the incompatible time-sharing system, right? You can see some attitude in that name, deliberately making something that was incompatible, right, with other things. But what they were doing was operating systems research, learning how to write an operating system, and doing some really innovative research for the time. But there was in this lab, there was a switch to proprietary software in the early 80s, and in particular there was a time when proprietary software companies started building up, and they realised that these programmers in the AI lab were really good programmers. And they basically tried to hire almost all of them away. So a lot of the AI lab programmers were hired away by proprietary software companies, and they were then locked away where they couldn't share the results of their research with other people, and instead they were paid to work on programming full time, which was great as far as them getting an income. Probably they were earning more than they would have got as students at MIT or academics or whatever they were, but it meant that there was no longer nearly as much sharing of their research going on, so we had a bit of a stall in the development of operating systems as seen by the public, as seen by people who were observing from the outside. So there was a particular incident that happened that I mentioned yesterday, which was this Xerox printer incident, where after an upgrade to the printer, the new version of the software came with a license agreement that required that the users of the software not distribute any changes. So if they had a fix to the software that ran the printer at MIT, they couldn't give that fix to, for example, the Berkeley University, right? It meant that you had to go back to the original maker of the software, Xerox, and beg for them to put in the change, and if they felt like it, if they had enough time and inclination, they might make the change in a future release that might come out 6 months or a year later. And that's very different to what would have happened previously, where somebody at MIT would fix something or add a feature, and the next week somebody at another university would be using that feature. And you can see that software development happens a lot more rapidly if you're able to share your changes with other people. Now, Richard recognised this, and he took a very firm stance. He decided that software freedom was extremely important. He decided that it was the ethical duty of a programmer to share his changes with other people, right? And so he started a project that aimed to do exactly that, to share the enhancements to an operating system with other people. And that project, the first one he founded was the GNU project. And GNU project, anyone know what GNU stands for? GNU?
GNU's not Unix.
Yep, stands for GNU's not Unix. But then what does the GNU in GNU's not Unix stand for? The same thing. It's what's called a recursive acronym. And this is quite common in the hacker culture. You'll often see recursive acronyms in names. Anyway, so he chose this recursive acronym name, which is common in the hacker culture of the time, and this GNU project. And the GNU project, basically, was trying to create a complete free operating system. So they aimed to create a complete replacement for an existing operating system where all of the software in the operating system was free software where everyone could see the source code, modify it, and improve it. Right? Now they started small. He started with a number of utilities, and he modelled the operating system on an existing operating system, which was the Unix system. So Unix had come out from AT&T, and the Unix operating system is what you've all been using recently, or a Unix-like operating system you've been using recently. And now he didn't choose Unix because it was necessarily the best operating system around, but it was an operating system that was fairly well accepted, and so people were already familiar with it, and it was available already. It meant you could build the beginnings of the GNU project on top of existing Unix systems and replace the operating system piece by piece, utility by utility, replace them one at a time to end up with, the end goal was a complete free operating system. Okay? He then founded the Free Software Foundation in 1985, and that was more the political arm of the GNU project, where it aimed to promote the ideals of software freedom more broadly than just the GNU project, to promote it broadly in the developer, hacker, hobbyist community, in the software engineering community. So there's a good quote that he comes from his announcement of the GNU project, which is that, "I consider that the golden rule requires that if I like a program, I must share it with other people who like it. I cannot in good conscience sign a non-disclosure agreement or a software license agreement." Okay, so he doesn't like NDAs, non-disclosure agreements, he doesn't like software license agreements, right? And he wanted to be able to share the results of his programming efforts with other people, and he wanted other people to share the results of their programming efforts with him and with everyone else. Okay, the next major event, I mean there's lots of events, I'm trying to compress a 20-year-old or more than 20 years history into an hour here, so you'll understand that I'm skipping a lot of very important events. But this one is certainly an extremely major one. The GNU project was successful in creating a replacement for Unix, replacing pretty much all of the functionality of the Unix operating system, except in one area. They hadn't replaced the kernel. Now the kernel is the part that interfaces directly with the hardware and provides the core of the operating system that all of the applications run on top of. Now the GNU project had started an effort to create a kernel, and that effort was called the GNU Herd project. And GNU Herd had a fairly ambitious goals in terms of the architecture for the kernel. And it hadn't got very far by the time that the Linux kernel came out in 1991, the very first version. The GNU Herd project had got bogged down in the difficulty of meeting their goals of creating a very advanced kernel. So Linus Torvalds in Finland, he was hacking around with a semi-free operating system called Minix. This was an academic operating system produced by somebody called Professor Tannenbaum, and he had released the Minix operating system under an academic-style license, where it was a non-commercial license and there were some restrictions on distribution and usage of it, but it was used a lot in teaching of operating systems. The Minix operating system was used, in fact, in teaching here in the Department of Computer Science at ANU for a number of years. So Linus had been playing around with the Minix operating system, but he thought it was a bit too limited. He wanted it to work well, in particular, on the Intel i386 architecture that had just come out, which was capable of doing a lot more in terms of multiprocessing than earlier Intel architectures had been capable of, and it was affordable for a home computer. And so he wanted to write a kernel which would fit in with the rest of the utilities for the GNU project creating that missing piece, particularly targeting the Intel i386 architecture. Now, at the same time, he was a pioneer in a new style of bazaar style development. Whether he realised it or not, the type of development process he chose was what has later become known as the bazaar development model, where he encouraged people, anyone, to make contributions without being part of any sort of project team. And we discussed the bazaar model yesterday. It built on many existing GNU projects, so it relied on things like the GNU C library, the GNU C compiler, and many other existing GNU utilities to make up the user space and to be able to compile the kernel. And it also drew on the existing Minix community. There was quite an active Minix developer community at the time, and many of them were also frustrated by some of the limitations of Minix. And so a lot of the early people who started working on the Linux kernel came from the Minix community. And this is one of the earliest messages he put out. I think it might have been the first one. The subject was free Minix-like kernel sources for 386AT back in 1991. And he said, I can, well, almost hear you asking yourselves, why? Herd will be out in a year. I mentioned the GNU Herd, and it was always going to be out next year, like many projects. Or two, or next month, who knows. And I've already got Minix. This is a program for hackers by a hacker. I've enjoyed doing it, and somebody might enjoy looking at it and even modifying it for their own needs. It is still small enough to understand, use and modify, and I'm looking forward to any comments you might have. So that was the initial announcement when he said that he was going to be working on a kernel, a new Unix-like kernel, okay, particularly targeting the i386 processor. Now, this background, the GNU project and then the Linux kernel, does lead to one of the disputes I'm going to be talking about in one of the later talks on FOSS culture, which is that many people in the free software community believe that what you're running there in the lab should be called GNU Linux, because it started out as the GNU project's aim to create a complete free operating system, and the Linux kernel provides the kernel for that, so together they provide the overall system. Whereas other people see it as principally the Linux system, because they came from a different background, and in that background they see that Linux is like the banner that they have fought under, fought the good fight under. And so I sort of refer to it both ways. In some of the lectures you may hear me talking about GNU Linux, sometimes I talk about Linux. Some people are very strict on it being called GNU Linux. So just be a little bit careful when you're talking in the community. If you see it in a mailing list that people are mostly talking about GNU Linux, then you should probably follow along with that. Otherwise you could end up in a major flame war. But you should also respect the reason why people want it to be called GNU Linux, because the GNU project has made an enormous contribution to the current state of FOSS, and they deserve recognition for that enormous contribution and the vision that Richard had to create a complete free operating system. Because without that original vision, you wouldn't have the operating system that you can run today. Okay? The BSD projects. Now, there's a lot of different BSD projects. They all are descendants of the original AT&T Unix. So AT&T, as you know, is a big telecommunications company in the United States. And they had a famous research arm. And that research arm produced a new operating system called AT&T Unix, right? And that operating system was originally distributed fairly widely among academic institutions. It was originally started in the time when academic software development dominated, and there was a whole lot of people who took the AT&T Unix system and did research, operating systems research, based on that system. Now, what happened then was the CSRG group, the Computer Science Research Group at the University of California in Berkeley, started doing research on operating systems based on AT&T Unix, and they started producing and releasing a number of distributions of the Unix system that where they had significantly modified portions of it, and they labelled their new distributions BSD. Berkeley software distribution, because it's from University of California in Berkeley, right? And what they did was their first release back in 1989, the net/1 release, was released under a freely redistributable license. So anyone could then give the sources to anyone else. But portions of the system, fairly large portions of it at that time, still relied on the AT&T source code. And that AT&T source code, AT&T was starting to ramp up its licensing efforts, where it was trying to get people to pay, in fact requiring that people pay for source licenses. And they often did sort of site licenses for whole universities or for departments or for other academic institutions. So AT&T derived some revenue by selling source code licenses to AT&T Unix. Berkeley, their portions of it they released as free software, right, under a license they called the BSD license, right, which is a very simple license they used. And we'll look more at the BSD license in the next lecture. So we had this mixture which was partly under a freely redistributable license, but which relied on portions that required an AT&T source license. So then in 1991 they did a net/2 release, a new version, and that was the first complete free Unix. It was the first time that you could have a complete system that basically had all the main features of a Unix-like system, but nearly all, or 99% of the source code was freely redistributable. So it replaced almost all of AT&T Unix by that stage, and kept it compatible, or mostly compatible, and in fact had many more features than AT&T Unix, particularly in the networking area. They had some advanced networking features. Now that release led, in fact, that release and the creation of some companies to sell support for those releases, a company called BSDI, which sold also commercial derivatives and support for those BSD releases. That led to a lawsuit between Unix Systems Laboratories, USL, and BSDI. Now that lawsuit was a defining moment in the IT industry as far as how do copyrights and licenses work on software. And that lawsuit lasted a number of years, and the lawsuit was eventually resolved a few years later, but during that period, the uncertainty over the result of the lawsuit led a lot of people to not want to use BSD Unix because they weren't sure whether they were going to be allowed to use it into the future, right? So there was a cloud hanging over BSD Unix, which made it very uncertain for developers as to whether any work they did on BSD Unix, they'd be able to continue working on it if USL won the lawsuit and BSD had to withdraw its distribution. Then if you'd done research on BSD, you might have lost all the research, you could no longer use it. So what happened, that was, I think, a major factor in the success of Linux, because at that same year, 1991, was when Linus Torvalds released his Linux kernel. And people saw an opportunity then, okay, we can work on the Linux kernel, which contains no source code from AT&T Unix. It's released under also a freely redistributable license. And so developers could be sure that if they hacked on the Linux kernel as opposed to the BSD kernel, that their work would be available into the future and it wouldn't be wasted due to some lawsuit. Okay? So, after that, but that lawsuit, by the way, eventually was resolved and it was settled. There was a very small number of files, I think half a dozen or so files that had to be modified in some small way. Basically, the BSD camp won the lawsuit to a large degree, and they settled and they were allowed to release future versions of it as free software, but they had to change a small number of lines of code in the release according to the result, the court order. But the changes were really quite minor and didn't impact on people's ability to continue their research on BSD. Okay, so rise of the lug. This is starting at around 1992, 1993. In Canberra, we started our Linux user group in 1993. That's when Linux user groups started rising all over the world. And these user groups were basically like the hobbyist groups, like the homebrew computer system for the very early hobbyist microcomputers. but centered around this new Linux system, particularly the Linux kernel and the user space, which consisted largely of GNU tools, plus a whole lot of other things like the X Windows system from MIT and other tools that people contributed from all over the world. And so those groups led to a lot of activity in the Linux community. A lot of people getting together at lug meetings, they were able to swap the software because downloading and distributing the software back at that time in 1992 wasn't quite as easy as it is today. You didn't have ADSL modems, we tended to have slow links, you may not have even had a permanent internet link at all, you might not even have a modem, many people. And so what tended to happen was people came along to Linux user group meetings and swapped great piles of floppies containing early distributions, or once CD-ROMs were invented a little bit later, started swapping CD-ROMs. And so I had a little service at my house where people from the Linux user group here in Canberra could come along to my house with a stack of blank floppies, and I would copy a Linux distribution onto those floppies and give it to them, and they'd then go away and install it and come back to a lug meeting the next month, and we'd all chat about what they were discovering, and they'd worked out how to install it, or they'd worked out how to recompile the latest kernel or whatever. So this sort of grassroots movement grew up, and that fed the people who participated in those early lug meetings and early lug groups became the core of today's Linux community. And so many of the people who turned up to the first lug meeting here in Canberra are still extremely active in the free software community. And the same is true of many, many lugs all over the world. Okay. It was a major distribution channel for early distributions. So Linux distributions started coming about in around 1992 up to 90, and then these are the earliest ones from 92 to 94. They started, the very first one that I'm aware of was H.J. Liu's boot root floppies, where he had a couple of floppies and you would boot off one, then you have sort of root file system on another. And so these couple of floppies would contain the complete Linux system. And it was in fact possible to have a complete working Linux system on a single 1.4 megabyte floppy. Right? I had a little one that I used to carry around, and I'd go into computer stores and make sure that the computer there would work with Linux and test it, right? And see if it's a good computer to use with Linux, with a single floppy that would boot up to a usable system on a 1.4 meg floppy. Now it doesn't fit on a floppy anymore. It's got a bit bigger than that. You tend to use CDs and DVDs. Although you can trim it back, and you may be able to, with some compression, to get something vaguely working on a floppy. Little tricky. Yeah. Sorry?
The kernel fits.
You can fit the kernel, but the user space has to be trimmed down quite a lot to fit you're not going to fit X Windows on a floppy.
If the good Lord meant us to use floppies, he wouldn't have given us USB sticks.
Exactly, right. Okay, so then some simple full distros followed. The MCC and TAMU distributions came out. And I think MCC is the Manchester computer. From memory, I think it's from Manchester, and TAMU was from the Texas A&M University in Texas. That's digging that deeply out of my memory. I hope I've got that right. So these were more complete distributions. They were tended to be text-based. X Windows integration came a little bit later, or X Window integration, I should say, came a bit later. And these distributions were quite primitive compared to today's Linux distributions. They didn't have the fancy mail systems and these sorts of things. They tended to come with much simpler utilities, but they were usable, full Unix-like systems, extremely usable. And a lot of people ran servers based on these. I had a server here at ANU. That little server Arvajau under my desk here as a student here at ANU eventually influenced the department, and now you know that most of the department runs on GNU Linux. So SLS was the first end-user distribution. It really aimed at people who were less hobbyists and more trying to really use Linux as a end-user system. Yggdrasil came out in, I think, 93, and that was the first commercial distribution, named after a Norse god. So it was sold commercially, but it was also available free, and sold on CD-ROMs, and it had some interesting features with live file systems and that sort of thing. Quite innovative system. The Slackware system, which of all of these ones, Slackware is the only one that's still around today. So Slackware is still quite popular today, and it was very popular in 94, 95, around that time. And again, it was really aiming to try to make running a Unix-like system, running a Linux system, much, much easier. From there, we got a huge explosion, and now there are many hundreds of Linux distributions available. The particular one you're using here in the labs is called Ubuntu, but there are hundreds of others which have specialist purpose in various specialist uses. Okay, then we had a bit of a rise of corporate interest with the dot-com boom. So particularly in the late 90s, a whole lot of companies started thinking, hey, this free software thing is really taking off, can we make money out of it? Right? And a number of people discovered ways to make money. And so the time of it was a good time to do this sort of thing because the amount of scrutiny of business models during the dot-com boom was very low. Business models just had to sound vaguely plausible for investors to throw money at it. And there was a period of time when Linux was the buzzword that companies had to have. And so you would see companies that really had nothing to do with Linux manage to put the word Linux in their press releases because they thought it would give them a positive impact on the stock market. And so we occasionally saw companies put out press release announcements about the fact that they'd installed a Linux server, right? Completely irrelevant to their business. But they put out these announcements because, hey, they're doing Linux stuff, let's buy their stock, right? And they had these sort of crazy attitudes, right, in the dot-com boom. And there was some very strange business stuff going on at that time. But out of that, a number of business models arose that were really quite successful. And those business models are still around today that survived. There are a number of business models that arose at the end of the 90s that didn't survive, but quite a few of them did survive. Linux programmers were suddenly in great demand. Right? If you could spell Linux, then you'd be hired and you'd be paid a good salary. And if you could pronounce it, even better. You'd probably become CEO or something. It was really quite crazy at the time, and a lot of Linux programmers went from being hobbyists to being professionals. But they carried across into their professions, in most cases, the free software ethics and development models that they used back when they were hobbyists. So many people are paid to work on free software, but their first loyalty is to the projects and to the community rather than to the company they work for. That's really quite common. Now a huge proportion of software for GNU Linux systems is written by people who are paid by companies to work on it, and that's continued to this day. It also coincided with sort of an internet boom and World Wide Web boom. That's supposed to be not book, that's supposed to be boom. I'm sure there were lots of books as well, but there was a sort of boom on the internet, and that of course made it much easier to do collaborative development worldwide. The World Wide Web and internet sites really helped the Linux development process. Okay, a whole lot of new business models sprung up, selling support, funding, selling support for the software, funding from hardware makers to try to make their hardware more attractive, and also some server Linux distributions started arising. So companies like Red Hat started selling distributions that were targeted at people running Linux as a server. Now, people had been using it as a server for many years before that, but now there were particular distros targeting the server market with enterprise features, right? Features that were targeting the use in large companies, in large enterprises. The open source initiative came about also in the late 90s, and that coincided with the rise of corporate interest in free software. Some people found the free label troublesome, and they found that people in boardrooms didn't always understand what free meant, and they couldn't really spend the time to read a paragraph or two to explain it. They wanted something simpler, right? They wanted, many people thought that there would be greater acceptance of free software within the corporate community if we could put a different label on it. And so a new label was invented. That new label was called open source. Previously, the term open source was in fact already in use, but not really applied to software. It was applied by organisations like the CIA and the FBI regarding sort of intelligence gathering. You know, there was an open source was like a newspaper. But anyway, open source was then applied to source code. And they wrote the open source definition, which was based upon the Debian Free Standard guidelines. That was written by Ian Murdoch, I believe. I should check on that. So now the open source definition was written and was tied to the trademark. Now one thing that's a little bit interesting is the trademark, the term open source is trademarked, but not as a bare term, open source. It's trademarked when it's tied to a particular symbol, a bit like an omega type symbol or an O type symbol, with open source written underneath it, in particular colours and things. There was an attempt by the OSI, the Open Source Initiative, to trademark open source in general on software, but that trademark failed, and instead they trademarked just the symbol that they use, and so you can't use that symbol unless you follow their guidelines on the use of the term open source. So this, of course, led to a bit of a split within the community of those who call it open source and those who call it free software. And you can see from the name of this course that I'm basically taking a bet both ways and using the term FOSS, which is what many people use these days, to be free and open source software, right? And the two, the open source versus free software, have a slightly different emphasis, but they have much more in common than they don't. There is a lot in common between them. They're really working on the same software, just a slightly different emphasis on the priorities of the two. Prioritising the freedom versus prioritising the quality or the technical aspects or the business aspects of the software. Okay, so that's a part of history of FOSS, and hopefully it gives you a bit more of an idea where it came from. We've now got, I believe, morning tea, and then let's have a look at our schedule. So morning tea now, and then we're going on to the next lab. Now, many of you haven't completed the previous lab, so it's fine to complete it during this lab. So I would like you all to send and receive a patch from somebody, just so that you've done it at least once inside the lab. Also note the message I sent to the discussion forum this morning, where I noted a way to use the Evolution mailer to send a patch without it wrapping the line endings, so mangling the patch. So please make sure you get through that second lab, and then the aim of the lab after that is really to settle on what project you're going to work on this week. So that's to pick a project that you want to contribute something to or research this week, and the end result of that is on Saturday you'll be giving a 10-minute presentation to the rest of the class on what you've learnt this week. Now that presentation doesn't have to include actually having successfully contributed a patch to the code. In many projects that would be well nigh impossible within a few days. But you should at least have done the basic research on the project. In particular, if you look at the lecture yesterday, if I go back to the lectures page, and we had a lecture on getting started in a FOSS project, and there was a particular page there which was the key project attributes, that page there. So at minimum, what you should do on Saturday is present this type of information about your project, right? Show what research you've done. Now, some projects, some of these things may not be relevant, and if they're not, that's fine, but at least have done this sort of research on your project and present that, and hopefully present it in some ways interesting to the other students. If you can find something that's interesting about the project, try and present that as well. Okay, so thanks very much, and enjoy morning tea.
Have a good afternoon.
It's a great. I really like it.